Hey there, this is the lecture video for Chapter 7, Section 4, last section of the chapter. Good job. We're back to the z-test in this one, so if you like to use the table, have the standard normal distribution table ready for this one. If you rather use the calculator, you'll want to refamiliarize yourself with the inverse norm function on your calculator. Okay, that's it. This one is pretty straightforward. Good luck. Welcome to the lecture video for Chapter 7, Section 4. Hypothesis testing for proportions. Today we're going to be focusing on one thing, how to use the z-test to test a population proportion P. We're going to wrap up our discussion of hypothesis testing for populations' different parameters. Now we're working with proportion P. A z-test for a population proportion is a statistical test for a population proportion. It can be used when a binomial distribution is given. Just like at the end of Chapter 5 and the end of Chapter 6, we're looking for things like NP is greater than or equal to 5 and NQ is greater than or equal to 5. We've dealt with that requirement before. The test statistic is the sample proportion P hat, which we've also dealt with. The standardized test statistic is Z. Here's the formula for this one. It should look familiar. Z equals P hat minus the population proportion P divided by the square root of the ratio PQ divided by sample size N. Let's go through in words and symbols how to use a z-test for a proportion P. First of all, we need to make sure that the sampling distribution can be approximated by the normal distribution. We do that by testing those products, NP and NQ, and make sure they're both greater than or equal to 5. If those check out, we can proceed. Next, we need to state the claim and identify our hypotheses. Remember, our null hypothesis will have some sort of equality symbol, and our alternative hypothesis will have an inequality symbol. And either one can be the claim. Then you create the complement for the other hypothesis. After that, we're going to specify the level of significance, identify alpha. Next, we're going to determine our critical value or values using the table number 4 in Appendix B at the back of your e-text or using your calculator inverse norm function. Those values are then used to place your rejection regions. Then you find the standardized test statistic using the formula and sketch the sampling distribution. Next, you make a decision whether to reject or fail to reject the null hypothesis based on whether the test statistic is in the rejection region or not. Finally, you interpret the decision in the context of the original claim. Okay, let's do an example. A researcher claims that less than 69% of U.S. adults who use live television streaming platforms have upgraded to advertisement-free service tiers. In a random sample of 100 U.S. adults who use live television streaming platforms, 65% said they have upgraded to advertisement-free service tiers. At alpha equals 0.01, is there enough evidence to support the researcher's claim? Okay, so we start by making sure we can approximate this normally. What is our N value, our sample size? It is 100. What is our P value? That gave us 0.69. So what must Q be? Remember, that's the complement. 1 minus 0.69. That's 0.31. So we need to multiply 100 times 0.69. We get 69. And we multiply 100 times 0.31, and we get 31. Both of those are larger than 5, so we are good to go with the z-test. Now we move on to stating our hypotheses. The claim is less than 69% of U.S. adults who use live television streaming platforms have upgraded to ad-free service tiers. So the claim is less than, which means an inequality. So which hypothesis does that go with? Alternative hypothesis. So pause the video a moment and write your null and alternative hypothesis. You should have gotten this. The null hypothesis is P is greater than or equal to 0.69, and the alternative hypothesis is P is less than 0.69, and that's the claim. Our next step is to identify the significance level. We can use the standard normal table or the inverse norm function on our calculator to find the critical values using the significance level in decimal form, because that is our area. Remember, we press second button, then bars, then arrow down or press 3, that is our inverse norm function selection, then enter, then type in your area, then press enter as many times as needed to calculate. In order to come up with the rejection region, you'll need to graph the critical value. Your result would be negative with the calculator, but how can you be sure that's the version of the number you use? Remember, you need to look at the alternative hypothesis for the nature of your test. It will tell you whether it's one-tailed, two-tailed, and left or right-tailed test. In this case, it's less than, so it's a left-tailed test. So we would use the negative number we got from the calculator, and the rejection region would lie to the left of our critical value. Next, we need to plug everything into the formula. We assume that p equals 0.69. Pause the video for a moment and do this. Here's how you should have set up the formula, and you should have gotten about negative 0.86. You can see about where the critical value of negative 2.33 would be, and the rejection region would be to the left of that. And the standardized test statistic lies to the right of it, so we fail to reject the null hypothesis because it does not lie within the rejection region. There is not enough evidence at the 1% level of significance to support the claim that less than 69% of U.S. adults who use live television streaming platforms have upgraded to ad-free service tiers. So what do we do if the sample proportion is not given? Well, we've seen this possibility before, and if it's not given, we can say that X, or the number of successes in the sample, divided by N, or the sample size, is the sample proportion. Let's do another example. A researcher claims that 26% of U.S. adults ages 22 to 59 who do not have a parent with a bachelor's degree have completed a bachelor's degree themselves. In a random sample of 7,400 adults ages 22 to 59 who do not have a parent with a bachelor's degree, 1,984 say they have completed a bachelor's degree themselves. At alpha equals 0.10, is there enough evidence to support the researcher's claim? Okay, so first we have to test the products. Our sample size is 7,400. What is P? P is 0.26. So what is Q? That would be 0.74. So 7,400 times 0.26 is about 1924, and 7,400 times 0.74 is about 5476. And both of those are greater than 5, so we can use a z-test. Next, we state the claim. In this case, it is that 26% of U.S. adults ages 22 to 59 who do not have a parent with a bachelor's degree have completed a bachelor's degree themselves. Pause the video and write what the two hypotheses should be. Here's what you should have for null hypothesis, that p equals 0.26, which is the claim, and for the alternative hypothesis, that p is not equal to 26. Then we determine the level of significance and the nature of the test. They gave us alpha at 0.1, but what is the nature of the test? Is it a one-tailed or two-tailed, right or left? It is a two-tailed test because it is not equal to. The alternative hypothesis is not equal to. Next, figure out the critical values using the significance level and what you know about the alternative hypothesis. Pause the video and do that now. The critical values are negative and positive 1.645. So what are the rejection regions? Those will be to the left of the negative critical point and to the right of the positive one. Okay, we're getting a picture of it. Now we're going to do that little tidbit mentioned before this problem. When we don't have a p-hat, or sample proportion, we use number of successes over sample size. So in this case, success is 1984, n is 7,400. Take a moment to figure that out. When we divide, we get 0.268. Now we can plug in the numbers to get our standardized test statistic. Pause the video and do that now. You should have gotten about 1.59. The only thing left to do is see if our standardized test statistic is in the rejection region or not. The figure shows the shaded rejection regions on both sides and where the standardized test statistic Z lies. It is just before the positive critical value, so outside the rejection region. That means we fail to reject the null hypothesis. There is not enough evidence at the 10% level of significance to reject the claim that 26% of U.S. adults ages 22 to 59 who do not have a parent with a bachelor's degree have completed a bachelor's degree themselves. Okay, that's it for this section and this chapter. Great job. Good luck on your Chapter 7 quiz, and I'll see you in the next video.